Hello DevOps Dreamer, welcome to DevOps Guru channel. In this video series, we will talk about Terraform. Before we dive in, if you are new here, consider hitting that subscribe button below and turn on notifications so you never miss out on any of our future uploads. Alright, without further ado, let's get right into today's topics. Welcome to Terraform series. In this video series, I'm going to talk about Terraform from basic to advanced level, covering interview questions. This is a complete package for Terraform with hands-on demo. Let's jump right in. Terraform is an infrastructure as a code tool, so we can create, update, and change resources. So what is infrastructure as a code means? It means instead of manually creating resources, we declare the resource needed as a code, and this code will handle resource creation, update, and delete. Let's talk about its benefits. Terraform is an open source infrastructure as a code tool. Terraform works with multi-cloud platform. It works with AWS, GCP, Azure, and many more. Terraform language is declarative, which means it describes an intended goal rather than exact step needed to reach that goal. So Terraform itself is responsible for figuring out how to achieve that state without actually defining all the steps, because current state of infrastructure is fully captured in code. Terraform is agentless. Terraform does not require any agent to be installed on managed infrastructure. Another benefit is collaboration. Since your configuration is written in file, you can commit to version control system and efficiently manage Terraform workflow across the team, and many more benefits. Terraform creates and manages resources on cloud platform and other services through their application programming interface. Provider enable Terraform to work with virtually any platform or service with an accessible API. Azure and Terraform community have written thousands of providers to manage many different types of resources and services. Providers are plugins that Terraform used to manage those resources. Every supported service or infrastructure platform has a provider that defines which resources are available and perform API calls to manage those resources. So provider understand API interaction and expose resources. This is an AWS provider page. Each provider has 3 tabs: Overview, Documentation, and Use this provider. This is Azure provider page. So you can see Overview, Documentation, Use this provider on top right hand corner. So registry is a main directory of publicly available Terraform providers. Provider is responsible for understanding API interaction and exposing resources. Terraform can auto-install provider from Terraform registry when you run Terraform init command. Let's go to Terraform registry, registry.terraform.io, and see providers. So when you go to registry.terraform.io, you can see providers, modules, and all other different types, but we'll talk later. So provider, we have 4,000 providers already. So let's browse providers. These are the provider list. It can go up to 83 pages, so list goes on and on. So mostly AWS provider, Azure provider, GCP provider, right? Let's learn about core Terraform workflow. It has 4 stages: write, initialize, plan, and apply. First, you write your code in HashiCorp configuration language to declare or define resources. That is your desired state. Then you initialize with Terraform init command, where Terraform download require provider as mentioned on the configuration file. Next command is Terraform plan, where it creates an execution plan describing the infrastructure it will create, update, or destroy based on your config. Next command is Terraform apply, where it actually provision your resources. So Terraform plan is just a preview of changes. Terraform apply actually does resource creation. So let's recap core Terraform workflow. We declare resource in configuration file. Then we initialize the directory containing config file with Terraform init command. Terraform plan give you preview of changes. and Terraform apply creates the resource generating a state file. State file is the single source of truth for Terraform. Terraform is able to figure out changes to perform based on what's on your state file, what is your actual infrastructure condition, and what is your desired state as mentioned on your config file. The prerequisites for this series are listed here. We need to install Terraform, AWS CLI, Visual Studio Code, and we also need AWS free tier account. Okay, let's talk about Terraform installation. As you distribute the Terraform is a binary package. All you need to do is download the package based on your operating system. Here is the link to download. So you can go to that website. Once you hit click, it's going to open the install Terraform. So choose based on your operating system, Mac OS, Windows, and Linux. So all you got to do is just hit download button, start downloading. Now go to that folder. So I have this one. This is the binary I'm talking about. So just copy that binary and save it in any location. I create a Terraform binary folder, and inside this folder, I paste that binary we downloaded from internet. Now all you gotta do is edit the environment variable. Just copy this path, go to environment variable, edit environment variable, and go to environment variable, go to path, not this one, go to double click on path and new and paste that path. Click OK, click OK, OK here. Now you can check the Terraform installation. Go to command prompt, and in the command prompt you say Terraform -- version. If we get the output, so get the output that Terraform version that we install, that means we successfully installed Terraform. Let's talk about AWS CLI installation. Follow this link to install AWS CLI. Just click on this link. It's going to take you to this one, this website right here. So you have Linux, Mac OS, and Windows installation. I'm going to show you Windows installation. Just go to the instruction. Now you can download MSI installer. So just click on this MSI installer. It will download the MSI file. All you got to do is just click next, 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 next. I accept, next, next, then install. Yes. Now it's going to start validating and downloading file. I'm going to skip forward this one. Okay, so it finished installation. All you got to do is hit finish button and make sure you check the installation through command lines. So all you got to do is AWS -- version. If this one provide you this link, that means you successfully installed the AWS CLI. So let's talk about Visual Studio Code installation. We need source code editor to write the configuration file. Code editor of my choice is Visual Studio Code. You can download editor of your own choice. So the link is code.visualstudio.com. So you can go to this link. Then you can download based on your operating system, Mac OS, Windows, and Linux. I have Windows, so I'm gonna do Windows installation. Just hit the installation button. You see the link is downloaded. You just follow along. Then open the file. Okay, I accept. Next, next. Visual Studio Code. Next, next. Install. Okay, so Visual Studio Code installation is successful. Just hit finish button. So once you download Visual Studio Code, you open the Visual Studio Code editor. Now we're going to talk about extension. Extension give you extra functionality. So Terraform extension give you feature like auto completion, syntax highlighting, formatting, and many more. Let's install Terraform extension. So go to extension right here and you type Terraform. And this is the one, HashiCorp Terraform. This is the official one, official by HashiCorp. So you hit install. I already have it installed, so I don't need to reinstall. So you guys see install button over here. Click on the install button. It'll auto install. We need free tier AWS account for this demo. So AWS offer 3 types of services: free trial, 12-month free, and always free. Let's go to this link, awsamazon.com, and it's going to take you to this website so you can explore more. So 3 types of services: free trial, 12-month free, always free. Under free trial, you can see this many services. Under 12 months free, this many services, and you can explore more. And you can hit create a free account right here to create an AWS account. So it's going to ask you for the root use email. So this one, and you can provide any account name. Let's say DevOps Guru. Then hit verify email address. Now it's going to send email to this account. So let me bring it up here. So once I hit refresh, I'm going to say verify email address, right? This is the code. I'm going to copy and paste it here. Verify. Email has been successfully verified. Now you're going to it's going to ask you for the password. Any password you can give. Okay, so all good. Okay, so continue. Now it's going to ask you basic information, and you provide your name, address, city, postal code, then go to continue. Next step is going to ask you the credit card details. It won't charge you until you went over the free trial, right? Free services. So in this demo, we're not going to go above free trial. So Terraform must authenticate to AWS to create infrastructure in AWS. There are different authentication methods. You can authenticate using AWS CLI, parameters, environment variable, share credential, config file, and many more. Before you can authenticate, you need to create an user with access key and secret access key for Terraform to use that user. So let's go to AWS Management Console and create a user. So I'm already logged into AWS Management Console. I'm going to head over to IAM, Identity and Access Management. Now I'm going to go to Users, create new user. Username can be anything. Terraform user. We don't need console access. Next. Now we can attach policy directly. So I will give you administrator access. In real world, we just limit the access, whatever access the user needed, but go with the administrator access. This user will have all the access in this account. Next. Now we're not going to talk about tag. Next, I'm going to create the user. Now Terraform user is created. Let's go inside the user. Now inside user, you go to security credential. Now create the access key. So this access key is just like username and password when you log into the console. But when you log in programmatically, you use this access key and command line and understand Next, create access key. See, this access key is just like username. This secret access key is your password. These are sensitive information. Do not share with anyone. I will delete this access key and secret access key after this demo. So don't try to hack me. So make sure you copy this in a safe place. Okay, to specify parameters in the provider configuration, we can set region, access key, and secret key directly on the config file. So this is not a recommended approach. If your secrets are hard-coded into configuration file and committed to source control, they may be compromised. So other setting you can provide are profile, config file, and credential file. Okay, so when we download AWS CLI, right, you will see .aws folder. Inside that AWS folder, you will have config file and credential file. So config file contain region information and credential file contain access key ID and secret access key. So these are sensitive information. You can create custom profile with different access key and secret access key, then refer that to the provider block. As you can see, we create a profile with the name custom, which we refer inside the provider block. So the default path for config and credential file is in AWS folder of users home folder. If you want to use other file in AWS Terraform provider, you will need to modify this parameter. Share config file and share credential file, the path. You need to provide that path. Authenticate using AWS CLI. First, you need to install AWS CLI, which we already did in previous video. Then open the terminal and type AWS configure. Paste your access key and secret access key created earlier. Then your provider block will be empty. This is the recommended approach. So to use environment variable option to authenticate, credential can be provided by AWS _access _key ID, AWS _secret access key as an environment variable. The region can be set using AWS _region environment variable. In this case, provider configuration block will be empty as the credential needed for authentication are pulled from environment variable. To set environment variable, use export command in Linux or set command in Windows. You can use IAM role for authentication. The provider block will look like this, where you need to create a role in AWS first, then provide the role ARN inside the provider block. Now we have completed authentication part. It is now time to write Terraform configuration. We define infrastructure using declarative configuration language known as HashiCorp Configuration Language, HCL. The Terraform language is declarative, which means it describes an intended goal rather than exact step needed to reach that goal. We define the desired state in our configuration file using HCL language. When we apply that configuration file, Terraform will provision resource to match the desired state. HCL syntax is easy to read and write. It is a JSON-like syntax with file name ending with .tf extension. The configuration file contains 3 blocks: Terraform block, provider block, and resource block. All 3 blocks can be in a single file or can be in a different file. So we are now ready to create our first infrastructure. This is a sample Terraform configuration file with all 3 blocks, that is Terraform block, provider block, and resource block. Terraform block contains provider information. Provider block contains information about provider, authentication. Resource block defines component of your infrastructure. Let's focus on resource block. It declares component of our resources, i.e. infrastructure. Syntax to create a resource block is given here. It starts with the resource keyword, followed by resource type, which you can get it from Terraform documentation. Then any logical name that Terraform used to track the resources. Then we provide resource argument inside the curly braces. Terraform documentation will provide required argument reference for that resource. Okay, now we are going to write Terraform configuration file. Once file is ready, we will apply that configuration file and verify infrastructure creation. Then we will modify the file and see its effect on infrastructure. Then at the end, we will destroy the infrastructure. Let's go to registry.terraform.io. In here, let's browse the providers. We are interested. We're going to create a AWS resources. Let's go to AWS. In here, you can see overview, provider, and documentation. So the provider, you can just copy paste the provider block as is. It'll work. And go to documentation. So in documentation, you will see different types of resources. All these are types of resources. We are interested in creating VPC, AWS VPC. So let's go type VPC and hit enter. Now look for each resources will have resource and data source, resource and data source. So we're going to talk data source later on. So let's find out our resource VPC under resources. So we are going to create AWS underscore VPC, this one. This type should match your configuration file, AWS underscore VPC. This is the basic example, right? And these are the arguments reference. It will provide each resources will have argument reference. These are some are optional, some are required, right? These are optional. For VPC, there is nothing required. You can just do empty block, right? So let's go to Visual Studio Code and create our resources. So I have Visual Studio. Let's go to Visual Studio Code, File, Open folder, and go to Desktop. Create this empty folder. So on this folder, let's close it out. So let's create a file in here. So Terraform file, always configuration file will always end with .tf extension, main.tf. You see the logo right here, auto pick up. So main.tf. Now in here we need 3 blocks. So Terraform block. Oops. Main.tf. Terraform block. Then we have provider block. Then we have resource block. So 3 things. So Terraform block will contain required provider. What provider you want out of those 4,000 providers? So required providers. See, auto give you. And required provider, we are interested in AWS. Cool. So let's give AWS detail. In this one, we need source and version. Control and space will give you the version. So these 2 value we need to get it from documentation. So source, if you go to source will be HashiCorp/AWS, HashiCorp/AWS, and the version is 546.0. You can go here, you can get the more detail. This is the latest version, 546.0, AWS underscore AWS HashiCorp/AWS. So let's give source HashiCorp/AWS, version is 5.46.0, right? Okay, so this is done. Now provider block, which provider we want? We want AWS. So we have to give authentication information right here. Either you provide in the configuration file or you provide in a through AWS CLI. So for this, you need access key that we created earlier, secret key that we created earlier, and reason. So reason US East 1. Okay, so you provide that secret key, whatever you downloaded and whatever you downloaded, right? So we have, so this hard coding the access key, secret key in your config file is bad idea. So you're gonna remove this one. You can give, look at the terminal. So to authenticate using AWS CLI, all you need to do is AWS configure, right? It will ask for access key ID and secret access key. So copy paste that. You just put whatever number you get it from there. Then it will ask you secret access key. Put that in there. Mine is already configured, so I don't have to redo it. And it will ask you reason. US list 1 is the default reason. I'm okay with it. And output format is JSON, so I'm okay with it. You don't need to provide anything. Just hit enter. So you successfully configure the authentication part. That provider block, the authentication, you don't need to provide here. You don't need to hard code the access key, secret access key here. Okay, now let's go to resource part. Resource part, we'll start with resource keyword followed by resource type. The resource type is you go to documentation and get that resource type, which is AWS _ VPC. So let's go to here. So let's go to documentation. So type VPC. So AWS _ VPC. That is the resource type. So let's go here. Resource type is AWS. VPC. Name is any logical name that Terraform use. You can say demo VPC. Now you need the argument reference. So for Terraform, per VPC, there is no required arguments. Now, you can see the arguments. You do Control F and required is nothing required. So only thing is this is not a required. This is a provider one. So the only thing pop up is this. So there is nothing required arguments. See, none of the arguments are highlighted. So you can just go without it, or you can provide CIDR block, right? So let's go here, CIDR block. So you can give CIDR block of 10.0.0.0/16. Control S, save it. Now we have configuration file is ready. Terraform block, Terraform know which provider to download, which version of the provider. Terraform has the authentication information through AWS CLI. Terraform know which resource to create. All three blocks are ready. Now we are ready to, our config file is ready. Now what do we do? Terraform init, Terraform plan, Terraform apply. Let's do Terraform init. Look right here. Right now is the only main.tf file. When you do Terraform init, it will download this provider. Terraform init. So it's initializing the backend. It is installing the provider. You see now .terraform hidden folder is created. Inside that you'll see providers, AWS, the version we mentioned, it download that version. So now provider is downloaded. Now we need to do Terraform plan. Terraform plan will give you the preview of changes that Terraform going to perform. So let's do Terraform plan. So Terraform plan says plus means it will going to create. What it's going to create is a VPC. So this is the one we say the CIDR block, right? It's going to add one, no changes, no destroy. It's going to add one VPC. So to actually create a VPC, you need to do Terraform apply, right? It's going to now actually create. Now see state file is generated. So it's asking us, I'm going to add one. Are you okay? The S is the only accepted value. You need to provide S. Yes. Now it's going to create a VPC. See, it's already created a VPC. Let's go verify that one. So let's go to VPC. So in here, so this is a default VPC. This is the VPC we created. This is not a default. See 10.0.0/16. This VPC is just created using Terraform. So we have created a VPC. We initialize, plan, and apply. Let's create a subnet inside a VPC, right? So let's modify. We can do another subnet, right? So the first subnet, you go to Terraform documentation. So put subnet. So under resources, AWS, this is the data source, not under data source. Under resources, AWS_subnet. That's the resource type. This should exactly match. And this is a basic usage. So what are the required? There is for subnet. Let's see what are the required. Control F required. So pop up 3 items. So under argument reference, the VPC ID is required because subnet goes inside VPC. So we need VPC ID. That's a required field. All other are optional field. So VPC_ID AWS_subnet is a resource type. So resource type AWS_subnet. So you can give any logical name. So there are one required field which is VPC_ID because that's the one it will the subnet go inside the VPC. So what's the VPC ID? You can get the VPC ID using its name right here. C or V. So how do you get it? So go to VPC, demo VPC. I need the ID of that VPC. So this is how you refer VPC ID. Now that's it. We need, but we can give extra parameters CIDR block for subnet. So what's the CIDR block for subnet? So let's give 10.0.128.0. We can give 10.0.0.0/17. That's a CIDR block. Save. Now our resources added, right? VPC is already created. Now let's do here. Okay, now do Terraform. Now we don't need to initialize. It's plan and apply. Terraform plan. Let's see what it does. So Terraform is refreshing the state file and it says it's going to create a subnet because VPC is already created. So subnet CIDR block will be this, which we mentioned right here. It's going to add one, right? So let's create a subnet. Terraform apply. You can do -- auto -- improve. It won't ask you for S, no, this kind of questions. It'll automatically create the resources. So it's going to create one subnet inside that VPC. So subnet is created. See one resource added. Let's see that subnet. So this is the VPC, right? Let's go inside this VPC. We have created one subnet, which is this one, this subnet. Let's go to subnets. Refresh. So this is the subnet 0/17 that's created inside that VPC. Go to your VPC. This is our VPC we created. This is the subnet just created, say 10.0.17. That's the subnet created. Now create a subnet. Right now we are going to create a virtual machine, which is our infrastructure. Right. Let's create one more resources. Resource. Under that is what's the resource type. All you gotta do is go to here and type EC2 or instance. So Elastic Compute Cloud resource AWS underscore instance. Name is resource type is AWS underscore instance. What are the required field? Control F and required. So we need AMI is required unless launch template is specified. We are not using launch template, so AMI is required. And let's see what others. Instance type is required. Those are required field under argument. Okay, that's all we need. So let's create a EC2 instance. So resource type is AWS underscore instance. This one name is server 1. Let's go. Now we need what? AMI. See this one. What else? We need instance type. Instance type is t2.micro as free tier eligible, and AMI you can get it from AWS. Let's go to here. VPC. You can go to instance. Good. Okay, this is a AMI type. AMI. So for this one, we can use this. This is AMI is talking about. In each region, AMI will be different. So be careful. I'm in Northern Virginia. The AMI is this one. This is US East one. So I can paste this one. So this AMI, this instance type, that's all I need to create a EC2 instance. So let's do clear. Now let's do Terraform plan. It's going to add one EC2 instance. Refreshing. Now it says Terraform plan says it's going to create one server instance of, let's see, one EC2 instance, right, of this AMI. Now if you are happy, Terraform apply -auto approve. It will create one server, one AWS EC2 instance. See, Terraform state file is here and state log. You cannot use state. Other person cannot use this Terraform config right now because it's in a log creating. Now you can go to the AWS console. Go to AWS management console and instances. There should be one instance coming up. You see, instance coming up. This is the one. This is initializing. See, one resource is created. Right? We created the instance. Now let's go to S3 bucket. We're going to create a S3 bucket. So resource. So S3 bucket will be AWS underscore. You can go to always refer documentation to find the resource type. So I already know S3 underscore bucket. Now You can give any name, any logical name, demo bucket here. What are the required field? So you can go to documentation and check for required field. And I already know it needs the bucket name. So if you leave the bucket name empty, it will create a random bucket name. It will assign a random unique name. The bucket name must be globally unique. So let's see, bucket. So bucket name will be my Terraform test bucket. To make unique, I give random numbers. So that's the bucket. So that's it. Now let's go create a bucket. Terraform plan. It's going to plan refreshing the state. Now it says want to add. Now it's going to add the S3 bucket. Let's apply. Terraform apply auto approve. Now it's going to create the bucket with this name, my TF test bucket. Let's go to AWS. Search for S3. Go to S3 bucket. See, my TF test bucket. This is created in US East 1. Now buckets are ready. You can modify, right? Let's say you want to add tag to the bucket. Tags, tags take in key value pair. So let's say name equal my bucket and environment equal def. So you can add a tag. Now we modify the resource, right? Let's see what will happen. Terraform plan. Let's do a plan. Terraform plan will tell you what's going to happen. See, Terraform plan is stays update in place. This yellow sign. So it's going to add those tags. It's going to modify, right? So one to change, not to add, just to change the tag. And 0 to destroy. Now you can do Terraform apply. It's going to add the tag to that bucket. Right now we do not have tag to this bucket. Let's go to buckets. Okay, so properties. So there is no tag. So this tag already added. See Dave and those two tags we added from the Terraform. Let's edit and add one more tag manually, not from the configuration. Let's add location. Let's just add one tag. Right? We added one tag manually, but our configuration file does not have that tag, right? Only two tag, not the location tag. Let's see what's going to happen. Clear Terraform plan. So Terraform plan will tell you what it's going to do. So it's going to delete, see, it's going to update in place. It's going to delete this tag because we manually added, because it's not in our configuration file. That's our desired status. Terraform trying to match desired status with actual status. So desired status does not has this tag. Now it's going to delete that tag. So let's do Terraform apply and see that tag is removed. So we apply that tag. Now go to bucket and see this tag should be, this is the one we manually added, right? Let's do refresh. These tags are gone. See, environment and name only, that location tag gone. So that's how Terraform match desired status with actual status. Okay. Now let's create a DynamoDB table, one more resource right here. resource. So resource type is, you can always follow documentation, AWS underscore Dynamo DB table, this one, and any demo table, any logical name. Now this one has 3 required field: name, hash key, and attributes. So for DynamoDB, let's focus, go to our slides and talk about DynamoDB. So for DynamoDB, 3 things are required: name, hash key, and attributes. So let's say this is our DynamoDB table name. This is a hash key. Hash key is like primary key. This is a range key, short key, and this is another attributes, right? These are all attributes, but this is a primary attributes, hash key and short key. So for DynamoDB table, the required field are name of the table. What's the name of the table? What is the hash key? Hash key is required. Hash key is optional. So name, hash key, and attributes. Under attributes, you're gonna give the name. What's the name? And type. Type is SNB. So billing mode is optional argument. Valued value for billing mode are provision and paper request. Default billing mode is provision. If billing mode is provision, read capacity and write capacity are required argument. If billing mode is paper request, read capacity and write capacity are not required. Okay, so I'm on my Visual Studio Code. Here we need to provide name, name of the table, demo table 1, 2, 3. Now we need to give hash key. So hash key is, let's give ID. Now let's also give a range key, game title. Now we need to give a billing mode. So billing mode is paper request, and we're gonna give the attributes. Now we have attributes is a block. So here you're gonna give name. Name is, what is the name? So we're gonna give a game ID. This one right here. Name ID and name, and then the type. So type will take it. Is it a string, number? So this is a number. So I'm going to give N, capital N. And let's go give another attribute. Attribute. So it will take name, and name is this attribute right here. Copy, paste. Now it will take type. Type is, so this is a string. String. Okay, so now it's ready. So our config file is ready now. Let's save this file. File, save. Now let's go here. Terraform plan. So Terraform plan. So it's gonna add one DynamoDB table, right? Just so it's refreshing the state. Now it says one to add. That is this DynamoDB table. So I'm okay with it. Now let's do Terraform apply. Terraform apply, auto approve. So it's gonna create a DynamoDB table. So state file here, and then the lock is here. So it's creating DynamoDB table right here. So it's still creating. So it's one added. So one DynamoDB table is added. Now let's talk about Azure provider. There are several Terraform providers that enable management of Azure infrastructure. Providers are Azure RM, Azure AD, Azure DevOps, AZ API, and Azure Stack. We will focus more on Azure RM. Azure RM manages Azure resources such as virtual machine, storage account, etc. Azure AD manages resources such as users, groups, service principal, and applications. Terraform must authenticate to Azure to create infrastructure in Azure. There are different authentication methods. They are authentication using Azure CLI, using managed service identity, using service principal and client certificate, using service principal and client secret, and using OpenID Connect. Terraform recommend using either service principal or managed service identity when running Terraform non-interactively, such as when running Terraform in CI server, and authentication using Azure CLI when running Terraform locally. Let's talk about authentication using Azure CLI. We need to install Azure CLI. So follow this link, learn.microsoft.com. Now you can install on Windows, Mac OS, and Linux. So on Windows, just hit this button. It's going to take you to the installation right here, Azure CLI, and you can download MSI and follow along. Let's talk about authentication using Service Principal. Follow this link for the detail. Service Principal is an application whose token can be used to authenticate and grant access to specific Azure resources from a user app, service, or automation tool like Terraform. Service Principal access can be restricted using Azure RBAC role so that they can only access a specific set of resources. So we're going to do demo for authentication using Service Principal. So the steps are create a Service Principal and create a secret, do a role assignment, and then we update the provider block. Provider block will have client ID, client secret, subscription ID, and tenant ID. Hard coding this is not a recommended approach. So we can give them as an environment variable. So environment variable, you're going to set like ARM underscore client ID, ARM underscore client secret, ARM underscore tenant ID, ARM underscore subscription ID. Okay, I'm on my Visual Studio Code. So I have a sample Terraform code where we're going to create a sample resource group, demo 1.2 in East US. So I have a provider block, and in the provider block, we'll give authentication information. Right now, we don't have any authentication information. So in the terminal, let's save this one. Save now. Let's do Terraform init. So it's going to download Azure RM provider. So that's what it's doing right now. The latest version of Azure RM is done. Now let's clear the screen and do Terraform plan. Terraform plan should fail because we don't have any authentication information right now. See, so no authentication information, Terraform failed. So let's clear the screen. Now let's give authentication information here. Okay, we can give it authentication through Azure CLI. So we downloaded Azure CLI in the previous video. Now, once you download, so you hit AZ login. AZ login command is going to open up a browser. So select your account, Microsoft account. So I'm going to select this one. So it's going to ask you the password. Once you log in through Azure CLI, Terraform has authentication information. Now you can do Terraform plan. It should pass. Let's do Terraform plan. So you see right here, one to add, one resource group to add. Now there is no authentication problem, right? So we provided through Azure CLI. We did AZ login and we give the credential. Once AZ login is done, you can do Terraform plan. It works. Okay, now we did it authentication through CLI. Now let's talk about authentication using Service Principal. Let's do AZ logout. So we logged out. Now if you do Terraform plan, it's going to fail because we don't have authentication information. Now we work through Service Principal. Okay, it failed as expected. Clear the screen. So we are going to create a Service Principal. Let's go to Microsoft Intra ID. This is the Azure AD, previously known as Azure AD. Now go to Azure AD and go to App Registration and create a new registration. So you can give demo app any name and just hit register. Once the registration is done, you go to the secret and certificate. So right here, and create new. You can create a certificate, you can create a secret right here. We are interested in secret, so new client secret. So go here, you can give our authentication. You can change the date. So let's give 90 days and add. So this is your client secret. This one, you can only get once. So just copy in a safe place. So this one. Now we have created demo app service principal. This service principal need to access subscription to create the resources. So let's give demo app access to subscription role. So let's go here, subscription, this subscription, then go to IAM, then add role assignment, go to privilege and contributor, next to service principal. Now select members. Now our application name is demo. So demo app, right? This service principal. Select. Now review and assign and create the role. Now our app has full access to subscription. So we created a service principal and we create a secret and we assign a contributor access to that service principal. Now it's time to update our provider block. Provider block need client ID. So let's go here. So client ID and provider block also need client secret, and it also need tenant ID and subscription ID. Okay. So let's fill this one in. So client ID. So we're gonna go to console. So this is my demo app. So client ID is right here. Client ID. So copy this one, paste. Now we need client secret. That's the one we copied earlier. So when we create a secret right here, so this is our client secret. So let's paste this one. Now we need tenant ID. When you go overview, so you can see tenant ID right here. So copy this one, paste. Now we also need subscription ID. Let's go to subscription. So this one. Now copy this subscription ID. Okay, paste. So that's all we need. Let's save this one. Control S. Now, earlier it failed, right? Now it should pass because we provided the authentication information right here. So let's do Terraform plan. It should pass and it should say it's one resource group to add because we give all the information it needs. See it pass. So hard coding the credential this way is not a good idea. So we can provide through environment variable. So we're going to pass it through environment variable. So export ARM underscore client underscore ID. So these are the things we will pass. So client ID will be this one. Copy, paste this one. Client secret will be this one. Copy, client secret. Tenant ID is this one. Paste, and subscription ID. So we need subscription ID for B. Now we can comment this one out. So comment. Okay, let's run through the command line. So let's copy this one. Copy. Clear. So let's paste this one. So we can set this as environment variable. So this one is done. Let's set this one as environment variable. Copy. Paste. That's done. Now so let's set this one as environment variable. Copy. Paste. That's done. Now let's set subscription ID. Copy, paste. So all these environment variables are set. Client ID, client secret, tenant ID, and subscription ID. Now we can comment this one. We don't need this one. We can delete this one. So this can be comment out, right? We can delete this one. We don't need. So we're not hard coding the credential right there. So let's clear the screen. Now if we do Terraform plan, it should work. We should pick up the credential from environment variable. Let's save this one file. Save Terraform plan. See it works. So it's picking up credential from environment variable. So AWS and demo 123 resource group will be created. Let's recap. We created service principal and secret, then assign a role to the service principal. Then we update provider block or provide credential as environment variable. We can also create service principal with the role assignment using CLI. This is the command. You can create service principal with contributor access to subscription. Just replace subscription ID with your subscription ID. Follow this link for the detail. There are challenges while using service principal. Someone need to create service principal object, which is security risk. Client ID and secret are exposed to service principal creator and consumer. Object has validity of 1 or 2 years. So service principal has administrative overhead and security risk. That's where managed identity comes in. Managed identity are in essence 100% identical in functionality and use cases with service principal. In fact, they are actually service principal. What makes them different is managed identity are linked to Azure resources and not to an app or third-party connector. Managed identity exists in two forms: system assigned managed identity and user assigned managed identity. System assigned managed identity is linked to a single Azure resource. They also live with Azure resource, which means they got deleted when Azure resource got deleted. User assigned managed identity mean you first have to create it as a standalone Azure resource by itself, after which it can be linked to multiple Azure resources. Follow this link to authenticate using managed service identity. The provider block will look like this. Use MSI equal true and you provide tenant ID and subscription ID. A variable in Terraform is similar to variable in programming language. Variable is a container that holds a value. It can be used to represent different value at different time during execution of program. Variable in Terraform are a great way to define centrally controlled reusable values. Terraform supports 3 different types of variable: input variable, output variable, and local variable. Input variables are used to define values that configure your infrastructure. This value can be used again and again without having to remember their every occurrence in the event it needs to be updated. Variable declaration accepts those arguments: types, default, description, validation, sensitive, nullable. Type argument specify what value types are accepted for variable. A default argument specify default value, which then makes the variable optional. Description argument specify the description of input variable. Validation block specify custom condition. Each validation blocks require a condition and error message argument. This example checks whether the AMI ID has a valid syntax. If it's invalid, it will throw error message. Setting a variable as sensitive prevents Terraform from showing its value in plan or apply output. When you use that variable everywhere in the configuration, Terraform will still record sensitive value in the state. So anyone who can access the state data will have access to that sensitive value in clear text. Declare a variable as a sensitive by setting sensitive argument to true. Nullable arguments in a variable block control whether the module caller may assign the value null to the variable. Default value for nullable is true. When nullable is true, null is a valid value for variable. Setting nullable to false ensure that variable value will never be null within the module. Input variable is declared using variable keyword and its value can be accessed as var.variable name. The types of value that will be accepted as a value of variable are string, number, bool, list, set, map, object, and tuple. So we declare the variable. Now we need to assign value to variables. There are multiple ways you can assign value to variable. Using command line argument, declaring variable value in files, or using environment variable. You can use the -var option multiple times in a single command line to set different variables. What if there are lots of variables? You end up declaring multiple var option. This is not a convenient way. To set lots of variable, it is more convenient to specify their value in variable definition file with a file name ending in either tfvars or tfvar.json. Then specify that file in the command line with var-file. Terraform also automatically load lots of variable definition file if there are present. They are Terraform.tfvars or auto.tfvars. Regarding environment variable, Terraform sorts the environments of its own processes for environment variable named tf underscore var underscore followed by name of declare variable. So when variables are declared in a configuration, they can be set in number of ways. The order of precedence matter here. Lowest precedence is given to environment variable and highest precedence is given to any variable values supplied through command line arguments. As you can see in the slide, the order of precedence increasing. Let's do a demo. So we're going to declare an access variable and we're going to talk about arguments. Then we assign value to variable through command line, files, and environments. Okay, let's start a demo for variable. So I have a var demo folder. Inside this folder, I'm going to create a file, configuration file. Let's say main.tf. And in here, I'm going to make Terraform block, provider block, then I'm going to create a resource block. So let's go from Terraform. In Terraform block, we have required provider, required providers. Required provider is Azure RM. So we're going to give a, inside this, we need to provide a source. Source is SC curve Azure RM. Then we need a version, this one. So value is 3.98.0. That's the version. Now Terraform block is ready. We need a provider block. Our provider is Azure RM. Inside this block, we need to give a authentication information. So feature block. Then we need to give authentication information. We will provide this through CLI, Azure CLI. So let's go to resource. We try to create a simple resource group. So the resource type for resource group is Azure RM underscore resource group, this one, and any logical name, demo RZ1, that's fine. Now inside this, we need two arguments, which is required. That's name of the resource group, demo RZ. So, okay, the location is, let's give East US. East US. So we have successfully created a resource with the demo RZ name and location. We don't want to hard code this. Let's introduce variable in here. So let's delete this one. We don't want to hard code name and location. So let's create a variable first. To use it, to access the variable, you have to create first, declare first. So declare using a variable keyword. This is a variable. Let's give a name of the variable. You can give any name. Let me give RZ name. So that's it. Now let's create another variable with the variable keyword RZ location. Location, that's it. So you have declared the variable. Let's access this in here. So you access using keyword var dot the name of the variable. Name of the variable is RZ name. Another one for location, var dot RZ location. So we have declare and we access it here. So let's save this file. Control S, clear. Let's do Terraform init. It's going to download the provider. Let's do Terraform plan. Terraform plan. See, it's asking for value for location, right? Because this is the name of the variable, and we haven't declared the value. So this is just a name. So that's why it's asking in the command line, give me the value for the location. So let's exit out of this. Clear. Let's provide a default value inside the variable. Inside this curly braces, you can provide different argument. That's type, right? What type of variable is this? Is it Boolean, list, number? So RZ name is a string. So we can also give, what's the description? The description is, so this is resource group name. and you can give the default value. Okay, let's give a default value, RG demo 123. Now let's do same thing for RG location. Let's go give type. Type is a string, and let's give a description. Description, this is RG location. Let's give a default value. Default value is East US. You can provide more arguments, like you can give a nullable, sensitive, validation. Nullable is true and false, sensitive is true and false, and validation is a block. Inside the validation block, it needs condition and error message. What condition? And if it's not true, it throws an error message. Okay, so let's go. Now we have declare the variable, access the variables, and we even provide default value. When we do Terraform plan, it should not be asking for the value in a command line, right? So it should pick up from the default value inside the variables. So I did a Terraform plan. Let's see. So Terraform plan pick up the default value from variables. RG demo. So this is not the only place you provide value to the variables. So you can assign value to variable through command line, through a file, and through an environments, right? So let's clear. So let's talk about assigning value to variables through command line. How do you assign value to through command line? So you do Terraform plan -var, then you're gonna give the key value pair. So you need to give RG name equal CLI RG, and -var RG location equal central US. Yeah, so each variable you just do -var key value pair, variable name and value, -var variable name and value. So you can provide, it's gonna work like that. So I did a Terraform plan. Let's see which one it will pick up. It will pick up. So these are the default value, and I provided through the command line. So it pick up from the command line, central US and CLI RG, right? So it is not convenient to give -var. What if there is a multiple variables, too many variables? So it's not convenient. So that's why we create a file. So let's create a file in here. So that's called, let's give terraform.tf bars. So inside here, you give the key value pair, just like you give it in the command line. So RG name equal, let's give RG from TF bars. Okay. So let's go give RG location also. Let's give West US. Okay. Let's save this one. Now, instead of going like this, -var, so it's inconvenient. Let's just give var-file. This is a file, right? Which file? It's a terraform.tf bars. Before applying, let's save this one. Now, when you do this, it should pick up from value from here, not the default value. And see, this is convenient to see it pick up from this file, terraform.tf. Let's clear. So terraform.tf bars, it will auto pick up. You don't need to give like this. You don't need to give var file. You do this, Terraform automatically pick up terraform.tf var file. Let's do this one without that -var -file options. Okay, so even though you haven't provided here, it's gonna auto pick up. See, it pick up from TFR. So what if I create a dev.tfvars and I'm going to give rg name dev rg location, let's keep east US. Yes, now if I do Terraform plan, it's going to pick up from terraform.tfvar. If I want to use these variables, so I have to give Terraform plan -var -file, then that file name. The file name is dev.tfvars, right? So let me save this before I apply. File, save all. Okay, so I apply dev. It should pick up this and this. Location and name dev rg and east US. Say it pick up dev rg east US, whatever we mention in dev.tfvar. So let me create one more file, dev.auto.tfvars. Okay, so let's keep rg name rg auto tfvars. Okay, so location equal, you can give any central US. Okay, let's save this one. Let me clear the screen. So let's do Terraform plan. What do you think which one it will pick up? So Terraform auto pick up this file. To pick up dev, you have to give -var -file. And let's see this one. So Terraform plan, if you do Terraform plan, let's see which one it pick up. It's pick up from this or pick up from this. So I did a Terraform plan. Let's see, it pick up from auto.tfvar because priority for auto.tfvar is more than terraform.tfvars, right? So let's do environment variable. Environment variable has lowest priority. So let's comment this one. Let's comment this one also. Comment this one. Now let's create a environment variable. So to create an environment variable, export tf_var, then the variable name. So rg name equal env-rg. So we created a variable. Let's do another one. tf rg location, give any east US. Okay. So we have created an environment variable. Always Terraform is looking for tf_var_ name of the variable. Okay, so now we have commented this one. Since this one is the least priority, we have to comment this one out. So let's do Terraform plan. So Terraform plan will pick up from, let's save all this file, save all. Now let's see which one it will pick up from. Now I did a Terraform plan. I have all these files are commented. So it should pick up from environment variables. See, it pick up from env-rg and the location. So the least priority is environment variable, highest priority is through CLI, and Terraform auto pick up these files, terraform.tfvars, auto.tfvars. Auto.tfvars are higher priority than terraform.tfvar files. A local variable assign a name to an expression so you can reference local multiple times, reducing duplication in your code. Unlike input variable, locals are not set directly by users of your configuration. Local variable is declared using keyword locals. Once a local value is declared, you can reference it as local.name of the variable. So let's do a quick demo about we declare using locals, then use using local.name of the local. Then when to use local variable is to avoid repeating the same value or expression multiple times in your configuration. So let's do a demo. I have a resource group resource here. I hard coded dev and east-us. So let's create locals. So locals with the S keyword, and inside this you give the name of the local. Let's give rg name equal, let's give dev, let's give another one rg location equal, let's give east-us. Okay, so we declare the local. Now we're going to use inside this. So let's not hard code this. So how do you access? Using singular local, L-O-C-A-L, not locals. Okay, just local dot name of the local. What's the name of the local? It's rg name and rg location are name. So for name is local dot rg name, and for this one local dot rg location. So control S. Now if we do Terraform plan, it should pick up this value from local. So the name should be dev and location should be east-us, because we are referencing locals from here. See, name is a dev and location is east-us. Output variables. Output variables can be used to print certain value in CLI output after running Terraform apply. A child module can use output variable to expose a subset of its resource attribute to a root modules. So child module export the value and root module will use it. So output variable is declared using output keyword. Now, how do you access child module outputs? In a root module, output of a child modules are available in an expression as module.moduleName.output name. Okay, let's do a demo about output variable. So let's declare output variable. Its keyword is output, and you can give any name. So let's give this one. Now inside this is value is a keyword. So inside this, you want to get this. You want to reference resource group, demo1 resource group dot this one. Now what do you want to get from this? You want to get the ID, location, name tag. So I want to get name of the okay. So this is the output. When you declare output and when you do Terraform plan, Terraform apply, you're gonna see this output in a CLI. Sometime when you do when we run Terraform through the CLI and we don't have a GUI access, and you can export those value in CLI. Okay, let's do Terraform plan. So I have Terraform plan. This is our output block, right? This output block will provide us name of the resource group in CLI output. See, it already give you the name of the resource group because it already know the name. What about ID? We don't. It will be known after apply, right? So if you want to capture ID of the resource group when you do Terraform apply, you need to mention in a resource output block. Let's do one more output block. So copy, paste. Now you need to get the ID, right? RG ID. So you don't want the name, you want the ID. This is the attributes. So let's save this one. Now let's run Terraform plan. So this time it's gonna output name, but the plan will not output the ID because it's none after apply. So you need to do apply also. So see in the output, name is already outputted because it's here. And resource group ID is none after apply. So you need to apply. So let's do Terraform apply. When you do Terraform apply, you will on the output you will see resource group name and resource group ID. You don't need to log into GUI and to get that. Let's give S to get that ID. The ID will be in a CLI output. In a CLI output, you will get name and ID. See, so you'll get the name and ID. This is the resource group ID. Let's talk about data sources. Data sources let you dynamically fetch data that is present outside of Terraform context. Example is AWS account number, AMI ID, availability zones, secrets, etc. You can use data sources to make your configuration file more dynamic. You can fetch AWS availability zone data from the data sources instead of hard coding on a config file. It's a two-step process. Declare data sources, and second one is access data sources. Each infrastructure in Terraform has its own resource block and data sources block. Just like resources, data sources has argument reference and attribute reference. The syntax to declare the data sources is data, which is keyword, then type of data sources, which we can find in documentation, followed by any logical name for the data sources, then provide argument reference. Once you declare the data sources, you can access it using syntax data.type.name.attribute reference. Now it's a demo time. So first we declare the data sources for availability zones. Then we can access the data source to create the resources. Let's go to Visual Studio Code and do this demo. Okay, so I'm on my Visual Studio Code. I have Terraform block and then provider block already here. And let's create a subnet. So to create a subnet, we need a VPC. Let's create a resource AWS underscore VPC. VPC name is any name. So VPC required CIDR block. So let's give a CIDR block 10.0.0.0/16. Right? That's all required for VPC. Now let's create a subnet. Resource AWS underscore subnet. That's the resource type. Subnet. So let's give this one sub1. So subnet, the required arguments is do this one. So which VPC this subnet goes into? VPC ID. So VPC ID is required. So we're going to get VPC ID from here. So this VPC, just copy paste. Dot this one. So what do we require? It's ID. VPC ID. Now we can give a CIDR block for subnet. CIDR block. So CIDR block for subnet is 10.0.0.0/17. Okay. Now availability zone. We want this subnet. Let's give availability zone. So availability zone. Where do you want it? You want it on US East 1. We don't want to hard code this value. We want to dynamically fetch it using data sources. So let's do that one. Let's not give this one here. Let's create a data sources. So the syntax to create a data sources is keyword data. So then data type. So for data type, you need to go to documentation. So right here, go to AWS provider, documentation, then type availability zones. So we are interested in data sources. Data sources, not the resources. So data sources, this one gives you availability zone, one availability zone. We need the list of availability zones. So this will give you list of availability zones. So this is the one. The data source type is AWS underscore availability underscore zones. This is the basic usage. You can just copy paste, declare the data sources. So what are the arguments? These are the arguments. Filters excluded is state. State is available, information impaired. So let's just go here. AWS underscore availability underscore zones. This one, right? This will give you list. You can give any name. AV Jones list, right? So let's give one attribute. State. State is available. So this will give you all the availability zone that's available in the region that we configure in the provider block. So we declare the data sources. This is declare data source. Now we're going to access right here. So how do you access? Thing is, you just copy everything, paste. Now go here, dot, then go here, dot. Then what are the attribute reference? So let's go to the documentation again. So these are the attribute reference. So this group's names, ID, names. So the names attributes give you list of availability zone names, right? So we have to put names, then this will give you the list. This will give you like this: US East 1, East 2, East, US East 1A, 1B, 1C, like this, right? So this is 0 index, this is 1, this is 2. So we want only one availability zone that's on the 0 index. So it will give you US East 1A, right? So our subnet will be created in US East 1A. Okay, so let's create another subnet. Copy, paste. Let's give this one sub 2. Now the VPC is going to same VPC. The CIDR block will be 10.0.128.0/17. Then the availability zone we want in on second availability zone, which is US East 1B. So we have two subnet. That subnet is going inside this VPC, and we create a data sources. We access right here. Instead of hard coding US East 1A, 1B, we dynamically fetch this value using data sources. Okay, let's save this file. Let's go to CLI, Terraform init. You need to download the provider, which is our provider is AWS. So it's downloading AWS provider, which we mentioned. Now provider is done. Let's clear the screen. So I did a Terraform plan. Terraform plan going to create a resource sub1 in 1A, which is our first availability zone. 1A. Now, so this is going to be in 1C because we give number 2, which is 0, 1, 2, US East 1C. And this is our VPC. 3 resources to add. Okay, more for accessing data from Azure Key Vault. Azure Key Vault is a cloud service for securely storing and accessing secrets. Secret is anything that you want to tightly control access to, such as API keys, passwords, certificates, or cryptographic keys. We are going to create Key Vault, then assign Key Vault administrator role to user. Then we are going to create a secret object inside the Key Vault. Then we use data sources to pull the secret in our Terraform config file. Okay, I'm on my Azure portal. Let's go to key vaults and create a key vault. So resource group, you can create any resource group. Let's give cyber key vault. It's okay. So key vault name is demo key vault 123 125. It should be unique name 148. Okay, so this is taken. So you can change the region or whatever you like. So I just give 7 days to retain. Then review. Then creates. So we create a key vault. Inside the key vault, you have 3 objects. So it's a deployment in progress. So inside the key vault, you have 3 objects: key, secrets, and certificate. So let's go to IAM, demo key vault, go to resources, then IAM, then add a role assignment. So look for key vault administrator, Next, select the members. So give it to DevOps group, select, assign the role. Now you have assigned the role. Now you can go to key vault. Let's go to secret, create a secret. Name of the secret is super secret. Now secret value is demo RG123. So let's create a secret. This is our super secret name, is the version. You can go to, this is our secret value. So you can see demo RG123. Hide the secret, close. Now we have created the secret. Now we're going to head over to Visual Studio Code and use that secret. So I have a resource group with the resource group name right here and then the location. So let's pull resource group name from the key vault secret. You can use it for anywhere you like it, but this demo we can focus on name of the resource group. So let's get data sources for Azure Key Vault, right? Azure RM key. So we need to get a key vault. So name can be anything. This key vault will get 2 arguments. So what's the name? So name of the key vault. So we give, which name we give? So key vault name is this one, right? Demo. This is the key vault name, demo key 148. So go to this key vault and it also take resource group name, which resource group you created. So we create that in cyber KB resource group. So let's go here, give the resource group. Now we have the key vault. We need to go inside the secrets, right? Let's create another data source. So Azure RM key. So we need a secret. So it takes 2 arguments. Number 1 is which secret, name of the secret. What's the name of the secret? So name of the secret is super secret. So you go inside secrets, super secret. This is the name of the secret. Copy. And it also take 1 argument, which key vault ID you need to take it from. So key vault ID is this one. Copy, paste. So dot. Now we need the ID of that key vault. So now we get secret data. We get all the information about this super secrets. So we created the key vault, went inside the secrets. The name of the secret is this one. And we're going to use it over here. So how do you access it? You access, all you got to do is get this. dot, delete this one, dot. Now we need dot. So what do we want? We want the value of that secret, right? So we want the value, that the value of the secret was demo. So right here, this is the secret. So you can go inside, see the value of the secret right here. This is the one, demo RZ123. It will pull it dynamically. So this is the value location. So your resource group name will be this one, demo RZ123, and the location will be East US. So let's save it and let's do Terraform plan. So Terraform plan will go to the key vault, go inside the secret, get all the data and provide this data to right here. Now see, so it's East US and name is sensitive because we are pulling from key vault. So you can do Terraform apply auto approve. So it's going to create a resource group with the name demo RZ123 because it's pulling from key vault. So let's see, it's creating resources. Let's go to, see, it's created one resource. Let's go to Azure and verify that one. Let's go right here and resource group. This is the cyber that we created earlier for key vault. It's coming up. See, demo RZ123, it picking up name from key vault value, demo RZ123. Let's talk about meta argument of resources. Meta argument in Terraform are special arguments that can be used within the resource block to control their behavior or influence the infrastructure provisioning process. They provide additional configuration option beyond the regular resource specific argument. We have 5 different meta arguments. They are depends on, count, for each, provider, life cycle. So depends on meta argument instruct Terraform to complete all action on dependency object before performing action on object declaring the dependency. Implicit dependency are dependency that Terraform can infer automatically from the configuration of resources. In most scenarios, Terraform automatically determines dependencies between resources based on expression within a resource block. There are rare scenarios, however, Terraform cannot infer dependencies between resources. In this case, you will need to create an explicit dependency. This is the purpose of Terraform depends on meta arguments. Terraform depends on allow you to create an explicit dependency between two resources. Dependencies are not limited to just resources. They can be created between modules. Let's do a quick demo on depends on. So I have a resource group with the name demo and virtual network with the name demo bnet. This virtual network is created inside a demo resource group. So if you do Terraform plan and apply right now, it will fail because it will try to create resource group and virtual network at the same time. It will not know, it cannot find the demo resource group and it will fail. So to fix this issue, we need to either create an implicit dependency or explicit dependency. So to create an implicit dependency, we need to refer, not hard coding the name. We can do this. Copy this one, refer the resource group dot demo dot name. So now Terraform knows we refer resource group name. So we're not hard coding, we're referring. So Terraform now know this is an implicit dependency. It will create a resource group first and then create a virtual network. Or other way is to, you can do the hard code that and tell Terraform explicitly depends on which one. So depends on this, depends on demo resource group. Now Terraform knows this virtual network depend on resource group. It will create the resource group first and then create a virtual network. That's what the explicit dependency is about. Let's do Terraform plan. So Terraform plan. So when you do Terraform plan, it should plan for resource group and virtual network. So demo resource group and demo vnet virtual network. So see to add. Now we need, so let's do Terraform apply hyphen auto hyphen approve. When you do Terraform apply hyphen auto approve, it will try to create a resource group first, and then it will create a virtual network, because virtual network depends on resource group. So Terraform will maintain the dependency. So let's see. So it's start creating resource group right here. So when the resource group creation complete, then only virtual network creation will start. See, it's still creating resource group. So until resource group creation complete, virtual network creation will not start. See, now the virtual network start, right? Because resource group creation complete right here, then it starts. So that's how it maintained the dependency. The count meta arguments. By default, resource block configure one real infrastructure object. However, sometimes you want to manage several similar objects without writing a separate block for each one. Terraform has two ways to do this: count and for each. Count meta argument accept a whole number and create that many instances of resources. So when to use for each instead of count? If your instances are almost identical, count is appropriate. If some of their arguments need distinct value that cannot be directly derived from integer, it is safer to use for each. Let's do a quick demo on count. So I have a provider block and then resource. I'm going to create AWS instances. So required parameters are AMI and instance type. So if I do Terraform plan, Terraform apply, this will create only one instance. What if I want 2, 3, 4 instance? Then we have a count meta arguments. So count accept a whole number. You want a 4, you want a 2, whatever number you want, right? Let's do 2. Then when we use a count, it will give us count.index. So we can use that count.index. Count.index give you the distinct index number starting with 0. If you give a count 4, then index will be 0, 1, 2, 3. So let's use that count.index here. Let's do the tags. So inside tags, you'll do name equal. So let's do this. So server count.index will be 0, server 0. It will be like tag will be server 0, server 1, right? We have a count 2. So let's do a Terraform plan. Terraform plan. So it should create 2 AWS instances, 2 to add, because it's going to create 2 instances. Now do Terraform apply hyphen auto approve. So it should be creating 2 AWS instances because we have a count 2, and then tag will be server count.index is server 0 and server 1. So it's creating server 0, server 1. 2 instances are coming up. So let's go to my AWS console and let's see. Let's refresh this. There should be server 0 and server 1 coming up right now. So it created 2 AWS instances with the tag server 0 and server 1. Terraform for each is a meta argument that helps in creating multiple instances of a defined resource. It also provides us with flexibility of dynamically setting the attribute of each resource instance created, depending on type of variable being used to create real-world replicas. For each primarily works with set of string and set of map of string. If a resource block includes a for each argument whose value is map or set of string, Terraform create one instance for each member of that map or set. Let's do a quick demo for each. So we're going to create a resource group with one resource group in location East US, another resource group in West US. Okay, let's create a resource group using for each loop, for each, okay, for each meta argument. So let's give for each. So to map, inside this, we're going to give a key value pair. So let's give first RZ equal East US, then second RG equal West US. Okay, so we have created for each. Now instead of giving the hard-coded name, so we're going to use the each.key, each.key, and this one we want to give the location. This is the key, this is the value. So we want to give the location as a each.value, each.value. So it's going to create this resource group name and this resource group location once, and again it's going to create this resource group name in this location. So let's do Terraform init, download the provider. Let's do Terraform plan. So Terraform plan should says a two resource group to create because it has two key. One this, another one is this, right? See, two resource group to add. One resource group is first, name is first RZ, location is US. So this one. Second one is second RZ West US. So it's going to create two resource group. So it's this one. Okay, let's talk about provider meta argument. You can optionally create multiple configuration for a single provider, usually to manage resources in different region of multi-region services. Each provider can have one default provider configuration and any number of alternate configuration with alias name. The provider meta argument specify which provider configuration to use for a resource, overriding Terraform's default behavior of selecting one based on the resource type name. By default, Terraform interprets the initial word in the resource type name separated by underscore as a local name of provider and use that provider's default configuration. By using provider's meta argument, you can select an alternate provider configuration for a resource. Let's do a quick demo for provider meta argument. Okay, so I'm on my Visual Studio Code. So I have provider, AWS provider, and two AWS instances, right? So if I do Terraform plan, Terraform apply, then these two resources, AWS instance, will be created in US East 1. This is my default provider, right? So what if I want to create this instance in US East 1 and this instance in US West 1? So I have only default provider. Then if I want to create in different region, then there comes a provider, alternate provider. So let's create another provider. So it's AWS, now region US West 1. So let's give alias. Alternate provider will have, you can only have one default provider and alternate provider will have alias name. So the value for alias is, let's give anything US West. Okay. So this is my, so this one is my default provider config. This is my alternate provider config, right? So I have two providers. Now, if I do Terraform plan, Terraform in Terraform apply, it's still going to pick up default provider because the default behavior is go to resource type AWS. So it's going to go to AWS. It's going to pick up the default provider. How Terraform know it needs to pull alternate provider is giving the resource, telling the resource, giving the resource provider meta argument. So let's give a provider meta argument, this one. So telling AWS, use AWS provider, but give the value of the alias. What's the value of the alias? It's US West. So let's give West. Now, if I do save now, so this resource use default provider, but this resource will use alternate provider. So this resource will be created in US East 1, and this one created in US West 1, because this one is using alternate provider, so which is US West 1 region, right? Let's do a Terraform plan. I already did Terraform init. So let's do a Terraform plan, see what it does. Oh, Terraform plan. So when I do Terraform plan, it should, okay, so I did not save it. So I save it. Terraform plan, it says to create. Let's do Terraform apply -- auto approve. So when I do Terraform apply, so I should see two instances created, one in US East 1, another one is US West 1. So it's creating right now. If I go to AWS Management Console, let's go to Management Console, and this is US East 1. So there should be one instance coming up here. See, this is one instance coming up, T2 Micro, US East 1. Now let me go to US West 1. There should be one instance coming up here also. Let's see this one. It's loading. So see, one instance in US West 1 is also coming up, is initiating. So don't worry about these are terminated already. Terraform lifecycle meta argument is a nested configuration block within a resource block. The lifecycle meta argument can be used to specify how Terraform should handle the creation, modification, and destruction of resources. The argument available within the lifecycle block are create before destroy, prevent destroy, ignore changes, replace trigger by. So create before destroy. When Terraform determine it need to be destroy an object and recreate it, the normal behavior will destroy existing first and then create the new object. Using this argument, the Terraform will create the new object first and then destroy the old one. This can help reduce the downtime. Prevent destroy. This lifecycle option prevents Terraform from accidentally removing critical resources. This is useful to avoid downtime when a changes would result in destruction and recreation of resources. Ignore changes. The Terraform ignore changes lifecycle option can be useful when attributes of resources are updated outside of Terraform. It can be useful, for example, when an Azure policy automatically applies tags. When Terraform detects the changes the Azure policy has applied, it will ignore them and not attempt to modify the tag. Attributes of resource that need to be ignored can be specified. Replace trigger by this option force the replacement of resource when a specific resource is changed. This may be useful when the resource reference another resource and need to be replaced when this happens. You can also use custom condition check within a lifecycle meta argument by adding pre-condition and post-condition block within a lifecycle block. So these, as you can see, lifecycle block with the arguments, lifecycle create before destroy true, right? Lifecycle another arguments, and lifecycle, this is the one ignore changes. This will ignore the change department, and if you do ignore changes all, the Terraform will never update the object, but will be able to create and destroy. And this is the lifecycle block within a resource block, and you can do condition check, precondition, condition, and error message. To another very important chapter in Terraform, we'll talk about state overview, local versus remote state, backend block, as well as workspace. So let's talk about Terraform state file. Terraform state is a virtual mechanism that records metadata about your infrastructure. This information includes not just the configuration you have written, but also identifier, dependencies, and other relevant detail of the resources that Terraform manages. Essentially, the state is a snapshot of your infrastructure at a given point in time, helping Terraform predict and execute changes efficiently. So mapping of your desired state, i.e. configuration file, to the real world resources is done through state file. It is the single source of truth for Terraform. Terraform uses state to determine which changes to make to your infrastructure. Prior to any operation, Terraform does a refresh to update the state with real infrastructure. This state file is stored by default in a local file named terraform.tf-state. It stores the state in a local JSON file on disk. Terraform recommends storing it in a cloud to version, encrypt, and securely share it with team. Backend block on the configuration determine where Terraform stores its state file. Backends are responsible for supporting state locking if possible. Not all backend support locking. What actually is state locking? With state locking, Terraform lock your state for all operations that could write state. This prevents others from acquiring the lock and potentially corrupting your state. State locking prevents concurrent run of a Terraform against the same state. Some of the examples of backend that support state locking are AWS S3, Postgres database, Google Cloud Storage, Azure RM. Please follow documentation for the details. So you go to this link and it's going to take you to the backend block. You're going to see all available backend right here on the left hand side. So S3 backend is this one. And this also support the locking. So this is the backend configuration for S3, right? All you got to do is just copy and put it inside the Terraform block. Terraform state contains sensitive data. The state contains resource ID, all resource attribute, database password, private key, etc. When using local state, state is stored in a plain text JSON file. Storing state remotely can provide better security. Terraform recommends storing the state remotely with encrypting the state data at rest. For example, the S3 backend support encryption at rest when encryption option is enabled. IAM policy and logging can be used to identify any invalid access. Another option is using Terraform Cloud, which always encrypt the state at rest. So let's do a demo for a backend block. When we're going to add backend block inside the Terraform block, when we add backend block, Terraform state file will be migrated from local to remote. So you will not see terraform.tf state in a local disk. Okay, I'm on my Visual Studio Code. So I have a Terraform block, provider block, and resource. We're going to create a AWS VPC. This is just one resource. So when I do Terraform init, Terraform plan, and Terraform apply, let's see what is going to happen. So I already did a Terraform init. Let's do Terraform plan. Terraform plan. So it's going to plan for adding one VPC. So say plan one to add. And when I do Terraform apply hyphen auto dash approve. So it's going to create one AWS VPC. So one to add is creating a VPC is done. So you can see state file right here. So state file is by default created in a local disk because we haven't mentioned backend block here. So the default is always on the disk, local disk. So let's add a backend block here. So backend. So it's a backend block is inside the Terraform block. So it's this Terraform block start from here, go all the way up to here. So we're going to add one nested block, backend block inside the Terraform block. So let's give a backend block as a type S3. So it needs three types of information. So bucket, it needs a bucket, and it also need key, and it needs region. Okay. So these three things we need to give. So we need to create a bucket, S3 bucket. Let's go to AWS Management Console and create one bucket. So let's go to S3. So, and let's create a one bucket. Create bucket. Let's give demo 5. The bucket name must be unique. So you see right here. So let's give a bucket this one and let's leave everything default. And let's create a bucket. So our bucket is created. This is the bucket name. And we created in a US West 1 region. Okay. Let's go to here. The bucket name is this one. We create in a region US West 1. And then the key can be anything. Let's give a key is the state file name. You can give terraform.tf state. Okay. So now we added the backend block. You're going to see this one will be migrated from here to the S3 bucket. Okay. So let's save this one. So let's clear the screen. So since you added the backend block, you need to redo Terraform init because Terraform init. So it's gonna initializing the backend. Is says we already have the state file locally. So do you want to migrate this to from local to the S3? That's what it's asking for. Let's say yes. So successfully migrate to S3. Now Terraform C. This one will be empty now. Nothing here. It went to S3 bucket. Now you're gonna see the backup of this one. Whatever in here is a backup. Right here. Now let's go to the S3 bucket and see. Let's go to S3 bucket. On this S3 bucket, you're going to see state file. This is state file now move from local disk to remote. Now you can do encryption and access control. So you have better security right here. Home workspaces are associated with a specific working directory and isolate multiple state files in a same working directory, letting you manage multiple group of resources within a single configuration file. Terraform start with single workspace named default that you cannot delete. When we run Terraform plan in a new workspace, Terraform does not access existing resources in other workspaces. These resources still physically exist, but you must switch to workspace to manage them. A common use for multiple workspace is to create a parallel and distinct copy of infrastructure to test a set of changes before modifying production infrastructure. These are Terraform Workspace CLI commands. Commands are very simple. This is just a Terraform workspace and then list, show, new, delete, select, right? List will list out all the workspaces. Show will give you current workspace you are in, and new will create new workspace. Delete will delete the workspace. Select will switch to workspace. Let's do a quick demo. I'm on a workspace demo folder. I'm going to create one file, main.tf. In here, I have a sample resource. So we're going to create AWS VPC. The provider is AWS. Let's save this one and let's do open a terminal. Let's get a terminal right here. Then I'm going to do Terraform init. When I do Terraform init, it will download the AWS provider right here. And it's downloading right now, the AWS, the latest version. So once it download, we can do the download complete. Now we can clear the screen. Now do Terraform plan. So Terraform plan will give you, then it needs to add one VPC. See, one VPC to add. Now let's do Terraform apply. Terraform apply dash auto approve. So it's going to create one VPC. So created the VPC. See, want to add, it's creating VPC now. One VPC is created. So state file is here. So we create the resources. Now we are working on default working directory. How do I know? Let's do Terraform workspace list. So this will give you list of workspace. So we have only one workspace and we are on the default workspace, right? Let's create more workspaces. So Terraform workspace. So how do you create the workspace? Terraform workspace new, and then the workspace name. Name is dev. Let's create a dev workspace. So it create the dev workspace and switch to that workspace. You see, once you create a workspace, you're gonna see new folder right here, terraform.tf state d. So inside here, you're gonna see dev folder. So that's for dev workspace. Let's create one more workspace, Terraform workspace prod. So it create the another workspace or prod. See, this is a dev workspace. This is a prod workspace. We have created. There is nothing right now. It's empty, right? This is our state file for default workspace. So let's clear the screen. Now we have created the workspace, right? Now which workspace we are in right now? So we can do Terraform workspace list. So it's going to give you 3 workspace, default, dev, and prod. We are in prod workspace. Let's switch to dev workspace. How do you switch? Terraform workspace select, right? What workspace you want to go to? Let's go to dev. So we are on dev workspace. You can do Terraform workspace list. It's going to show you what we are in dev workspace right now, right? So let's create a resource in this workspace. So we're going to do Terraform plan. So we already create a resource, AWS VPC, right? So it's going to create one more because this is a different workspace. This is a dev workspace. It says one to add. Let's apply. Terraform apply dash dash auto dash approve. So it's going to create one more in dev workspace, right? So it's creating. Now, when you go to dev workspace, you see state file is there because we created one more resource in that workspace, but we haven't done. Production workspace is empty. So this is a default workspace state file. This is a dev workspace state file. We create one resource in dev workspace. Now let's go to prod workspace. Let's switch. How do you switch? So Terraform workspace select. Now you go to prod, right? We are switched to prod now. Switch to prod. So let's create a resource in prod workspace. It's the same command. Terraform apply auto approve. So we're going to create a resources in a prod workspace. You see, it's one to add again. So it created. So when you go to prod workspace, you're going to see state file. So each workspace will have one state file. That's how with a single configuration file, this is your single configuration file, you can create multiple resources, look like it's multiple environments. So now let's delete the workspace. So which workspace we are in right now? So Terraform workspace list. Let's list out all workspace. So we are in prod workspace. Clear. Let's delete the work. Let's delete, right? Terraform destroy. So when you do Terraform destroy here, dash auto approve. So you are in production prod workspace and you're doing destroy. It only destroy the resources in that workspace. Now see it destroy complete. Now you go to Terraform. See backup is already created. This should be empty. See there's nothing in here. Now prod is gone. So we'll go to destroy. Now let's switch to we destroy the resource in prod. Now we have to go to the dev. Now let's go to the dev. Now we switch to dev space. Now we can do Terraform destroy auto approve. So it's going to destroy dev workspace also. See dev workspace state file is there. Now it's destroying. Now it's going to see backup is created. This is empty. So we have created the workspace We switch to that workspace, we create the resource in that workspace, we destroy the resource in that particular workspace. The previous demo will create exactly similar resources. Managing variable with Terraform Workspace is essential when you need different configuration for different environment, like dev, test, stage, and prod. This lets you create environment-specific resources using Terraform Workspace. First, you need to declare the variable as you would normally do for any Terraform configuration. Providing value to this variable can be done easily using TF-var files. For each environment, you declare a TF-var files like dev.tfvar, stage.tfvar, prod.tfvar. Based on the workspace you are on, let's suppose you are on dev workspace. You will run terraform apply --var -file dev.tfvars. Okay, I'm on my Visual Studio Code. I'm in the workspace with var folder. So let's create a file. main.tf. So this is the sample configuration. I have AWS provider. We're going to create AWS VPC, and the CIDR block will give variable CIDR, var.CIDR. This is the variable we declare. So right here is variable declaration CIDR, and we're going to provide, we declare the variable, but we're going to provide the value in TFR files. Let's create a TFR files. So not this one. Let's create a TFR file dev.tfvars. Let's create one more file prod.tfvars. So for prod.tfvar, our variable name is CIDR. So let's give CIDR for 10.0.0.0/16. Now let's give here our variable declaration CIDR. Let's give 10.0.0.0/24. Okay. So for dev is 24 CIDR, for prod is 16 CIDR. Okay. So we have a main.tf file which has a variable, and we have two tfvar files right here. Let's save all. Okay. So we have created declare the variable and provide its value in dev.tfvar. Now let's create an environment. Let's go to terminal. Yes. Okay, so in the terminal, let's create a workspace. So how do you create a workspace? Is the Terraform workspace new dev. So create a dev workspace. Let's create one more workspace, prod. So create prod workspace. So we are in prod workspace right now. So you're gonna know by Terraform workspace list. So we are in a prod. Let's switch to dev workspace. Terraform workspace, select dev. So we are in dev now. So let's create a resource in dev workspace. So Terraform init. So Terraform. So let's initialize the Terraform. It's going to download AWS provider. Downloading right here. So once it's finished download, we're going to do Terraform plan and Terraform apply. So this one is done. Init. Let's do Terraform plan. Here you're going to mention --var -file equal dev.tfvars. So we are in a dev workspace. We're going to use the dev variables. So dev has is going to create this /24 VPC. So Terraform plan is fetching this. You see this one. See the IDR block is 10.0.0/24. So Terraform apply --var -file dev.tfvars. So it's going to create the resource. Right now it's in creation. So let's say yes. So it's creating the VPC with 10.0.0/24. So let's switch to production prod workspace, Terraform workspace workspace, select prod. So we are in the prod workspace. Okay, let's do Terraform apply. So we are in prod workspace. So we're giving prod.tf vars. So this time it's going to pick up /16 CIDR block. See, this one is 16 CIDR block. It's asking for yes. So it's created the prod.tf vars. So when resource created, when you go in here, so you have state file for dev, state file for prod, but we are creating different resources. For dev, we are creating /24 CIDR VPC. For prod, we are creating /16 CIDR VPC, passing var-dash file based on the environment specific resources. Terraform is the same concept that you have learned in any programming language. Modules are the key ingredient to write reusable, maintainable, and testable Terraform code. Modules are containers for multiple resources that are used together. A module consists of a collection of .tf files kept together in a directory. Terraform modules, usually root modules, can call other modules to include their resources into configuration. A module that has been called by another module is called child module. Child module can be defined within the root module using module block, which specify the resources of the module, which specifies source of the module, and any input variable need to be set. The root module is a top-level module of Terraform config. It serves as an entry point of your entire Terraform config and typically include provider configuration and any variable that are needed to define your infrastructure resources. So root module is responsible for initializing Terraform, configure provider, and declaring resources. In child module, you create main.tf, variable.tf, output.tf. Child module configuration file will not contain provider block. In root module, you create main.tf, variable.tf, terraform.tf var. The configuration file contains provider block and you declare variable value in terraform.tf var. You perform terraform init, plan, and apply in root modules. So when you go to Terraform registry, you will see publicly available module, almost 16,000 modules. You can use that module and create the resources, or you can create your own module from scratch and create resources using own module. So this is a module directly from documentation. Let's go to documentation right here. So right here. So this is a VPC module. Terraform module to create AWS VPC, right? This module, let's go to README. So this is the sample usage. You just copy this one and you can create resources. So this one has the input variable. All these are input variable right here. So these are default value if you do not provide any, right? All these are default value. So, and the output are this will output these many variables. So let's go to documentation, README. Let's copy this one. So I'm on my Visual Studio Code. I'm on this folder. Let's create a file, main.tf. So let's paste that sample configuration. So this is a module. The source is this one right here. So name, you can give any. These are the variables. You can provide, let's say, demo VPC. You can change your CIDR block, whatever you need. These are the AZs list. See? You can give US East, whatever you like, and private subnet. These are the CIDR for private subnet, public subnet CIDR. Enable NAT gateway true. You can say, okay, so this one you can say false. I don't need VPN gateway. So tags, Terraform true, environment dev, or you can give stage, whatever you like, you customize. And now you save it. Now let's do terminal. Let's do Terraform init. It's going to download the AWS provider. Looking at the module, source of module, because this is the AWS provider. It's downloading AWS latest version of the provider. Still downloading. So download complete. Let's clear the screen. Now let's do Terraform plan. Terraform plan is going to create, let's see how many resources it's going to create using, see this one going to create 31 resources using these simple modules, right? So let's see, it's going to create a VPC, subnet, public subnet 2, public subnet 1, and it's going to create another public subnet in different availability zone, private subnet. It's going to create a private subnet on another availability zone. Now it's going to create private subnet again. Now route table associations with the public and private subnet. These are route table association. Also route table associations. Route table associations. These are route table, public route table, and private route tables. Right. So all these resources with the simple module you can create, and you can customize these variables the way you want. You can go to this one right here and look for, go to input value. These are the input values it will pick up. You can customize whatever you need. Here we are going to create our own module from scratch and use it. We are going to create child module and access that child module in the root modules. So let's go to Visual Studio Code and do this demo. Okay, I'm on my Visual Studio Code. Let's create a folder. This is a child module. Okay, let's create another folder here. Root modules. So under child module, we can create another folder, VPC. Let's create another folder for security group. You can create multiple modules. So let's focus more on VPC and security group only. So let's go to VPC and we're going to create main.tf, variable.tf. Then we're going to create one more, output.tf. So security group also, let's create main.tf, variable.tf, then output.tf. Okay, so let's focus on VPC module. So let's go to main.tf. Let's close all, go to main.tf, right? So here we don't need provider in the child module. So we go straight to resources. Let's create a VPC, AWS underscore VPC. So name can be anything, demo. So here we need CIDR block. So let's keep CIDR block in a variable, var.cidr, right? So we create this. Now let's create the variable for this one. Copy this. Let's go to variable right here. Variable. So let's paste that one. So we create CIDR variable. Now that error should goes away now. Yeah. So VPC is done. Let's create a internet gateway and attach to VPC, right? So resource. So AWS underscore internet gateway. This one. So name can be IGW. Now this one requires VPC. Which VPC this internet gateway will be attached to? So VPC underscore ID. So VPC ID will be this one, right? Copy, paste this one dot ID of that VPC, right? That's what we need. So we create the internet gateway attached to this VPC. Now let's create a availability zone list, right? So let's create a data for AWS underscore availability zones. So this kind of gives you AG list. So we don't need anything in here. So this is going to give you, okay, so that we create the data. So this is going to give you all the a list of availability zone in a region. Let's create a subnet. Resource, so AWS underscore subnet. So this is public sub 1. So the subnet required which VPC it going to. So VPC ID, again the VPC ID is this one. See, VPC ID. Then it required CIDR block. CIDR block. Let's give in a variable r dot pub sub. Okay, so let's take this one. Public subnet 1 CIDR. So we have the CIDR. Now let's give availability zone. Availability zone will be, so is this one. C. So this one. Let's delete this one. Dot. Now this one has attributes names. Then the names will give you the list. So which one you want? The first one, the list. Now map on launch, since this is our public subnet, we want that map public IP, right? We want the public IP for public subnet. So this is true and false except boolean. So true. Okay, so that's all needed for public subnet. So which VPC it going to? What's the CIDR block? Availability zone, we pull it from dynamically, pull it from data, and then map public IP true. So let's create this variable. So let's go to variable, paste it. So we created another variable. Let's create another subnet. So paste. Let's create public subnet 2. So same VPC. Let's go this one going to public subnet 2 CIDR. So we want this on second availability zone, and this is public, goes to true. Let's create a variable. This variable, copy. Let's go to variable right here. Let's create a variable, paste it. Okay, so this variable is done. The error goes away. Now we're gonna create a route table. Let's create a route table for public subnet, right? So resource. So AWS underscore route underscore table. This is the route table. So we can change this public route. So public route, that's okay. Now route table required which VPC it's going to. So VPC ID. VPC ID is same thing right here. C B. This goes inside the colon. So VPC ID. Now route table required the routes where it's going to. So route is a block. So inside this one, this required what CIDR block? The CIDR block, let's say 0.0.0.0. If it wants to go to 0.0.0, then where do you want to direct to? So gateway ID, you want to direct to internet gateway, right? Where is the internet gateway? Gateway ID, we need the ID of internet gateway. So internet gateway ID is this one. Copy, paste, dot, AWS dot, we need the ID of that gateway, right? So we create the internet gateway. Let's go here. Okay. So we have route table created. Let's associate this route table to two of our public subnet, right? Route table association is also a resource. So AWS underscore route underscore table underscore association. See this one. So this required subnet ID. Which subnet? So we want to associate to first subnet. This one right here. See. So we require the subnet ID. So ID. Then this one also required a route table name, right? Subnet, which route table. So route table ID. So route table ID will be this one. We're gonna associate, copy, paste, dot. So we need the ID of that route table. So that's how we associate first one. Let's associate second one. V route table. So sub 2, right? This one, this, and then the same route table. So we have associated the route table. Now let's create a private subnet. So let's copy this one. No, this is route table. This is the subnet. Copy, paste. Now AWS subnet. Let's make this private sub 1, right? Same VPC. So this is not a public. Private sub 1. See it here. Now availability zone. We want this private subnet in a first availability zone. Since this is a private subnet, this will be false. Okay. Let's create a variable for this one. So copy. Let's go here. Then variable paste. Now let's go to main.tf. Let's create another subnet. Another private subnet. Paste. We want this private subnet. Subnet 2. Same VPC. This is number 2. We want it on second availability zone, and we don't need a public IP on launch. Let's create this variable. Let's copy this one. Go to variable. Control C. Now variable. Now paste it. Now you go just align. So we have created public subnet and private subnet. Same way you can create a data subnet data in different availability zone. So I'm just going to leave it right here. So we have created the resources and we put variables right here. Now we're going to do output. So output, let's do ID. We need a VPC ID, right? So let's do value. What value we want to output? We want to output VPC ID. So this is the VPC ID. So demo ID. So this value will be outputted. So the root module can use this one. So control save. So our VPC is ready. So we have resources, create all variables. We have output right here. So our VPC module is ready. Let's create a security group module, main.tf, right? So I'm on my security group modules. So in main.tf, so security group main.tf, let's do a sample. So this is a security group. It's going to create security group with this name, this description, VPC ID, and we have ingress rule for 80, ingress rule for 443, and egress rule, right? So this is a security group. So we created one VPC ID. So this one. So let's create a variable for VPC ID. So var variable VPC ID. Let's align this one. Control save. Let's save all. So we have security group. This one. You can go output and do security group output here. So I have security group module. We have main.tf, variable.tf, VPC. We have main.tf, variable.tf, output.tf. So our two module, under child module, we have security group module and VPC module is ready. Now let's go to root module and do the same thing. So let's go root module, create a main.tf and variable.tf and Terraform.tf parse. So in main.tf, right, we need a provider also, because we haven't declared provider in a module. So provider AWS. Okay. Now, and then we need to call the module with the keyword module. Which module you want to call? Let's say VPC. This can be anything, the name of the module. When you do Terraform init, it download the module that you provided in a source field. So when you do this, see, it requires source. So source is, our source is in right here, VPC, right? We need to go one top level module here and then go to the VPC. So dash dash, see right here, child module and then VPC. So we're going to call that module, bring that module in here, and then all the variable that we declare in this module. There is a lot of variable we declare, right? All these variable we need to give that variables right here. Let's go here, copy this one. So main.tf, we need to declare all these variable, provide that variable. So CIDR equal var.CIDR. Then public CIDR, this one equal var.public subnet 1 CIDR, private public var.public sub 1 CIDR. G. So let's copy this one equal var.paste. So this one, remove this one, copy this one equal var.paste, then this one, copy this, remove variable and var.paste, right? So now we need to declare those variable also. It's just copy paste whatever in the VPC module. We just copy and go to root module, same variables. Now this error goes away. See? Let's align this one. Okay, so VPC module is ready. Let's call another security group module. So module, any name, security group. Now source is dash dash. So this one, side module, security group. Now we need a variable, right? In the security group module, what variable we declare? VPC ID, right here. So let's go here. So paste equal. We cannot provide this in var.vpc ID, right? VPC ID cannot be provided in the variables because this will be none after apply. So how we can do is we can do module.vpc, this one right here, module.vpc dot, this VPC has an output of ID. So we can use that. That's why we need to output that in a child module. So the root module can use these attributes. So let's go to here. So let's use ID. So this is also ready. So we call VPC module and provide that variables. We call that with security group module and provide that variable, because this we pull from module directly. So we don't need to declare in a variable right here. Okay. So it's time to give value to the variables now. Let's go here. So, okay, I'm on my terraform.tfr. We are going to provide the value to this variable, right? These variable values. So let's go here. Let's provide all these value. So these are the variables. We provide value to this variable in terraform.tfr files, right? So We created a, let's recap, we created a VPC module, we created a security group module, and on the root module, we call that module right here, and we provide all those variable required by that modules. Same thing right here, all these variable, and those variable values will be declared right here. We are ready to do Terraform init plan, and let's save this. Save all. Save. Now let's go to terminal right here. So we are in right here, module from scratch. So we are on the top level folder. Let's go to, you always do Terraform plan, Terraform init, and apply on root module. So let's go to root module, cd. So root module. So here you have main.df, terraform.df, and then terraform.tfr and variable.tfr. These are right here. So let's do Terraform init. So it's gonna throw error. I know what error is. So I want to show you guys. See. So it takes the name right here. This one is talking about the duplicate name right here. Main.tf. So not here. Side VPC. Main.tf. So this one. This is the same name. It has to be different name. So let's give this one name too. Let's save this one. Let's clear. Now let's do Terraform plan again init. So it's gonna download the AWS provider, which it did right here. Now let's clear the screen. Let's do Terraform plan, and let's see how many resources it's going to create. So state file is there. So it says it's going to add 10 resources, right? What are those resources? So VPC, then it's going to create a public subnet in second availability zone, public subnet in first availability zone, private subnet in second availability zone, private subnet in first availability zone, route table associations to those private subnet. Then this is a route table, public route table, internet gateway, and the first one is the security group. See, we call both module, VPC module and security group modules. So it's going to create all those 10 resources. Welcome to another chapter of Terraform series. We will walk you through the process of using Terraform import command to bring your manually created existing infrastructure under Terraform management. Importing your existing resources into Terraform ensure that your infrastructure state is centralized and managed through a single source of truth, enhancing visibility and control. Once imported, your resources seamlessly integrate with the broader Terraform ecosystem, allowing you to leverage module, variable, and other advanced features. Terraform imports only available in Terraform version 1.5.0 and later. The way to import resources under Terraform management is using this command, Terraform import resource type dot resource name followed by resource ID. This only update the state file, and you need to manually update the configuration file. Let's go to documentation and see. So when you go to documentation right here, you can go to right here import. It's going to take you to the import command. See this one right here for VPC. So all you got to do is Terraform import resource type for VPC will be AWS underscore VPC, and this is the logical name. This is a VPC ID. This is the old way. The new way is using import block. This block accepts two arguments, to and ID. We need to add a resource block manually, and after that you do Terraform init, Terraform plan, and apply. Then you comment out the import block. Let's do a demo. Okay, I'm on my Azure portal. Let's create a resource group manually, and let's go create. Let's give demo RZ resource group. Let's leave it on US East. Let's hit create. Validation complete and create. So we manually created a resource group. Let's bring this under Terraform configuration. Right now we have manually created. It's not in a state file. Okay, I'm on my Visual Studio Code. Let's create a file. main.tf. So I have a sample code right here. We have Azure provider, and we're going to bring Azure resource group. Resource group have name and location. So the one we just created, right? This one right here. The name is demo RG. Location is East US. So location is East US. Name demo RG, right? So now we have this one. Now when you do Terraform, any Terraform apply, it's gonna try to create this resource group. We are not interested in creating. We are interested in bringing this resource group we manually created into Terraform configuration. So let's add an import block. So import block has two arguments, to and ID. So to where do you want to bring it? You want to bring it under this resource group, right? So copy, so test dot. Okay, so the ID of the resource group. Let's go to resource group and properties. So this is the resource ID right here. You just copy and you just paste it in here. Paste. So the import block is ready. We want to import this to this resource block. So now let's bring up the terminal. New terminal. Yes. Okay. So let's do Terraform. Let's save this before we run and save. Terraform init. So we initializing backend. It's going to download Azure provider. It's downloading Azure, the latest version. That's done. Let's clear the screen and let's do Terraform plan. It should say want to import. So because we are not interested in creating, because this is an import block, it should say want to import. See, want to import, nothing to add, nothing to change, nothing to destroy. This looks good. Now I'm going to do Terraform apply. Terraform apply. So Terraform apply should say also want to import, 0 to add, 0 to change, 0 to destroy. So it's asking for, see, want to import. So I'm happy with that. Let's say yes. Now see, it imported. One imported right here. So the state file captured the resource group manually created. Now that manually created resource is under Terraform configuration. Now after you do apply, you just comment out this one. Let's comment out this one. Now save this. Now if you do Terraform plan, it should say resource is up to date because we have imported it our whatever on our config file matching with the infrastructure. So no change is required. So we have successfully completed this import, but here we manually give the resource arguments, right? What if you want to generate this argument, this block automatically by Terraform? Then there comes a generate config flag option. So this is another way which will auto generate config file. You declare the import block without the resource block, then you run Terraform plan with generate config flag. This will auto generate config file and review the generated file and run Terraform plan apply. After you apply, comment out the import block and we're going to do all this demo. So I'm on my Visual Studio Code. Inside the import config folder, I'm going to create a main.tf. So last demo, we left it like this, right? So we have imported using the import block and we manually give the resource arguments. What if this resource has a lot of other arguments? So we want this resource argument. Terraform automatically generate this resource argument. Let's delete this one and let's uncomment this. It's the same resource. We have the import block right now. Let's save this one. Let's bring up the terminal. Yes. So here we want to do Terraform. Let's initialize first. So when we initialize, it's going to download the Azure RM providers. So that's what it's doing right now. downloading. Now it's download complete. Clear. Now we want to generate that resource block, right? So let's use a Terraform plan dash dash generate dash config dash out. Let's give resource.tf. This file name can be anything, but it should not be here. The name should not be here. So rz.tf, let's give a simple name, rz.tf. So it's going to generate the resource group configuration. So let's run this one. So when you run, what's this? This is going to generate rz.tf file right over here. So it's importing still. So preparing to import. So it's see rz.tf. It's automatically downloaded. So config is in, this is in experimental stage right now. So be careful using this one, right? So we have rz.tf. Whatever we manually write down, the Terraform automatically generate. See, generated by Terraform. So be careful. So the last time we give this one and this one, these arguments, right? So, and these arguments are automatically generated. You can review this one, make necessary changes. Let's see, I'm going to delete this one. I don't need this, and I don't need the tags. So I'm good with it. So I change, review this automatically generated file, and then make necessary changes, save it. Now clear the screen. Now I do Terraform plan. So without the generate config flag, right? So I'm going to do Terraform plan. It should say one to import, nothing to add, nothing to change, nothing to destroy, right? So let's see what it's going to do. So this is our, see, one to import, nothing to add, nothing to change, and nothing to destroy. So I'm happy with it. Now let's do Terraform apply dash auto dash approve. So it's going to apply again. It should say one imported, nothing added, nothing changed, nothing destroyed, right? See, one imported. So I'm happy with that. Now we successfully import that manually created resources using generate config flag, and we automatically generate this rz.tf. Now you can comment out this block, comment this one, save it. Now when you do Terraform plan, right, it should says your infrastructure match, no changes required, right? We have imported whatever in our state file match with the whatever in the actually present in the cloud provider. So no changes required, infrastructure match. Okay, let's recap. So we added an import block, then we run a Terraform plan with generate config flag. Then we review that generated file, make necessary changes if needed, right? Then we do Terraform plan. The plan should says one to import and everything should be 0. We did a Terraform apply. So apply should says one imported. Then we comment out the import block. We comment out this block. Then we run Terraform plan again. It should says no changes required. Infrastructure matches the configuration. All right, DevOps Dreamer, that's all for this video series. Please like, subscribe my video. Thank you. Happy learning, happy coding.